Today we're going to talk about different types of theorems involving different types of segments that interact with circles. For these theorems, you'll never have to memorize them. You're just going to be able to look at a reference sheet and know which one to utilize when, because there are there's lots of different ways to solve each problem. So in theorem 1, it says, in a plane, a line is tangent to a circle if and only if it is perpendicular to the radius drawn at the point of tangency. Here's what this means. A tangent line, if you recall, is when it touches the circle once, but never goes through the circle. If you notice, it is touching our radius here. And in doing so, it's creating this right angle. Okay, what needs to be perpendicular. A lot of the times, too, there'll be an extra line drawing from here to here. Again, this is your radius. This little part from the center to here is also your radius. Oftentimes, when you see a picture like this, it's going to be a right triangle, which means we can involve Pythagorean theorem to solve, which you've seen already. Theorem 2 says if two segments are tangent to a circle, so you notice that these two segments are touching the circle on the outside here, but never going through it, to the same external point, so you'll notice these two tangent lines are meeting at one point, then these two segments are congruent, so this would be the exact same length as this. So if I know that this is 10, that means this is also 10. We've seen this formula, or this theorem, in previous lessons. The new ones are these when we have multiple lines, all right, in multiple different parts. So it says if two secant lines meet on the outside circle, the products of the lengths of one secant segment and its external secant segment equals the product of the other one. That means a whole lot, but here's how I remember it. How we do this is you take the whole secant line. So in this instance, the whole secant line is from C to A. And you times it by the outside part, whole times out. The outside part of that secant line is from B to A. That will equal the whole other secant segment. My whole other secant segment is A, E, times the outside part of the other one. The outside part of the other one is A, D. Okay. So how do you do this problem? For this example here, we know that C to B is X, B to A is 8, A to D is 6, and D to E is 10. So the whole secant segment of this one, from here to here is X, from here to here is 8. So that whole thing is X plus 8 times, all right, just the outside part. The outside part of that secant segment is 8 equals. For my next one, the whole secant segment is from A to E. So that's 6 and 10. So 6 plus 10 is 16 times the outside part. Well, the outside part is just that 6. And our goal now is to solve this problem mathematically. If I distribute that 8 in, I get 8x plus 64 equals, and then 16 times 6 is 96. Subtract the 64, and then divide by 8, and you get x is 4. Okay, so it's whole times outside times whole times outside. And to find those wholes, you just add the two little parts together. This next one is when a secant line, which is in our instance here is K to M, meets a tangent line, which is KJ. It has the exact same formula as the last one, whole times outside times whole times outside. So I'm going to write it down. Whole times out equals whole times out. So look at our whole line over here. My whole line is from K to J. So that whole thing is just one thing, so it's 8 times the outside portion of that. Well, the outside portion is also the exact same thing, so it's also 8 equals. The whole part of this secant line is from K to M, so from 7 and X, so that would become 7 plus X, times the outside portion. The outside portion of this is just from K to L, which is just 7. So we're going to go ahead and solve this problem. 8 times 8 is 64. If I distribute that 7 in, I get 49 plus 7x. Subtract the 49, I get 15 equals 7x. And then divide by 7, I get 2.14 equals x. final one here is when two chords intersect the circles. For this one, it is just one part of the chord times the other part of the chord equals one part of the second chord times the other part of it. So I call this one part times part equals part times part. So we're gonna look at the first chord here. My first chord is from A to C. One part of that chord is this 5. The other part of that chord is 12. If we look at my second chord is E to D. One part of that chord is X. The other part of that chord is 10. So now we just have to solve this problem. 5 times 12 is 60. X times 10 is 10x divided by 10, and I get that x equals 6. Again, you never have to memorize these. You just have to be able to look at a reference sheet and know how to utilize them.